Now that we've seen what the mole is, we're going to get to the application and show how to do a conversion to moles. So in this case, we're going to be using 3.24 times 10 to the 25th atoms. Very large number of atoms, but we're going to be converting this to moles using the value that was provided before. The way we'll do this is using dimensional analysis. So we'll be using strategies that we've seen before. So first thing that we'll do is we'll take our original value and set it over 1, like we generally do for problems like this. So once we put it over 1, we're going to need to figure out a conversion factor that will be used with this. We know that atoms will need to be on the bottom here in order to cancel. And since we're trying to get to moles, we're going to put moles on top. One thing you'll see here, and this is something that I'll keep doing in the future, is while it seems silly, the abbreviation for moles is MOL. So we essentially take off a letter. It's how it's commonly done, and so I'll be doing that as well. So just in case you see that in problems, the MOL is just an abbreviation for moles. We'll then need to fill in numbers that are appropriate with the mole part and the atoms part. Based on what we talked about before, we know that a mole is defined as being equal to 6.02 times 10 to the 23rd individual pieces. In this case, our individual pieces are atoms, so the 6.02 times 10 to the 23rd will go with the atoms. We'll put that on the bottom, and that is the same number of atoms as 1 mole of atoms, and so we'll put the 1 on top with the moles. This takes us through what we need to do for our setup, so we can see that the atoms part will cancel based on how we set it up, which is good for us. And now we should be ready to calculate. One thing that will be important for problems like this is, since we're dealing with such large numbers, numbers in scientific notation, we're going to have to be very careful about how we enter these into the calculator. The value that we should be getting from this calculation will be about 53.8 when rounded to proper significant figures. This comes from the fact that the 3.24 has 3 significant figures, so does the 6.02, and those are the only non-exact values that we have here, meaning that our answer should have 3 sig figs as well. So we end up with 53.8 moles at the end. As for how you would plug this into your calculator, there are a couple ways that you can do this. One is using the EE button that we've used in class. That is used for scientific notation, so the way that we would enter it that way would be 3.24, then you would push your EE button, which would show up on your display as just a smaller capital E, and then enter 25, the power of the 10. You then divide this, because the number that we are working with is on the bottom here, by 6.02 times, or in this case, to avoid the scientific notation issue, again, we can use our EE button. So show up on your display as a small e, 23, and that would accomplish what we need to do. So you would press equals after that. Another way that you could do this is by entering the scientific notation more explicitly, but this can lead to potential problems with order of operations. If we were to just put in 3.24 times 10 and then use our exponent button, 25, then divide by 6.02 times 10, and then again our exponent button, 23, and press equals after this, we would end up with an incorrect answer. That's because by the order of operations, we would first be doing the exponent part, so we'd do the 10 to the 25th and the 10 to the 23rd first. We would then go through and do the multiplication and divisions in order from left to right. What that means is that we would be taking 3.24, multiplying that by 10 to the 25th, dividing that result by 6.02, and then multiplying that result by 10 to the 23rd. This is not what we want to do, because if we look at the original stuff at the top, we can see that the 10 to the 23rd should be something that is divided by. It's on the bottom of the fraction. In order to correct this, we could use parentheses. So we could put parentheses around each of our scientific notation values, something like this, and that would correct the issue that we would have created by using the scientific notation and not being careful with our order of operations. However, the simplest way would just be to go back and use that EE button, which puts things into scientific notation directly, and then we don't have to worry about all of that order of operations. So that will take us through the example here of solving a problem where we are taking atoms and converting to moles. We'll go through one last example showing the reverse conversion where we're going from moles to individual particles. Again, we'll probably be using atoms as our individual particles.